Swayam Prabha. Digital India. Educated India.
So welcome back. So in this small cartoon movie, what you saw that there is a sudden the sea receded and then further it came back. So the point was that we should not underestimate the tsunami waves. So what we usually look at that in ocean you are having a very wide or wavelength, whereas close to the coast we have the stacking up of the waves and the height increases. So what we call this as an wave train, then height increases, velocity decreases, and it will be more damaging, whereas in the ocean the wavelength is very large. It can go up to more than 100 kilometers. And this portion, that is what you see is the trough, and this is your crust. So the trough part, when it comes first, it will result into the what we call the drawdown. So this will result into the receding of the ocean, exposing the coastal area. Now let us see further. What we look at is if you want to calculate the energy conditions or the energy of the tsunami to total energy, it has been given as ET 1/6 rho GH square A, and what it means is that you have a total energy of the tsunami. Rho is the density of the ocean water, and G is your gravitational acceleration. And then height is either you have the actual height of the crust or the crustal displacement. So you can assume the average height of the crustal displacement, and A is the tsunami generating area. So you need to have and how much is the area which was ruptured. Now this all parameters will be taken into consideration when we are talking about the modeling part, and that will be taken at the end. So and for that was in total energy. This is for the velocity of the tsunami waves. So if you have the tsunami velocity of the tsunami waves depends upon the water depth as well as the gravity, where c is the velocity in meter per second, d is the depth of the water column, and g is again the gravitational acceleration. So it will depend on that where exactly. So suppose you are having a subducting plate like this, and you have a water depth this one, so that will result into the effect, the velocity of the tsunami. So if you are having the earthquake taking place in this shallower part, then you will have the different effect. If you are getting the earthquake in the deeper part, that is a displacement mainly, then you will have the different velocity. So if you know this, that is your d, and you know you can calculate the velocity of the. So for example, what has been given here is that you have the square root of g into d. So if you have so this you know is 9.8, and if you estimate or if you know the depth for example, here it has been taken 4600, then you will get here the depth is 100, then you will get 3 point. So you can have the speed of the tsunami or the velocity of the tsunami. So again, if you are having the greater depth, that what has been shown here, so for example 4600 meters, then the velocity is much higher here. If you are having like depth is hardly 100 meters, then you are having the velocity is much lower. Now these are the areas which are extremely prone right from the, so this part which we have discussed is the part of the Pacific ring, or we can say the ring of fire, where we have most of the subduction going on, and this is the Chilean part which was responsible in triggering a 1960 Chilean earthquake. Magnitude was 9.5, and another one was triggered here of 2004, and magnitude was 9.3. So few major tsunami events in the Pacific. So we have listed here, you can just go through it. So this was the major tsunami. Whereas these are in Indian Ocean 2004, and then again 2018. So these are all Pacific, and below what you see is from the Indian Ocean. So you can understand that this was in September, and another was been triggered in 2018 again in December, and that was related because of the Krakatau volcanic eruption. So the destructive and the destruction which was been observed in 1960 Chilean earthquake. So this what I was showing, that we are having in this major subduction zones aligned along the ring of fire. This shows the 1960 rupture area and the directivity of the tsunami. So it took almost like 24 hours to reach the Japanese coast, and the height also, like you can see, the height close to the event is much higher, and it reduces further as it moves away from the rupture zone. So the largest subduction zone earthquake of May 22nd, 1960, Chile, magnitude 9.5, and another one is your, what we say is the 2004, 26 December, Sumatra 9.3. So this is 9.5 and 9.3. In some literature you will find that the 1964 Alaskan earthquake was been listed as the second largest. So these two areas were responsible of triggering the damaging or devastating tsunamis and large magnitudes, or we can say mega earthquakes along the subduction zone. So one was 1960 and another one is 2004. So let's see a case study of the Chilean earthquake, that is 1960 magnitude 9.5. So it took, if you see this, these are the time which has been given based on the modeling, it took almost 22 hours to reach this coast. So, as I was talking about that, no doubt the earthquake was been triggered here and the tsunami was generated, but the region which is sitting adjacent or adjoining the Pacific was affected. So, I will not get into the detail of this, but you can, when you get the slides, you can look at the details here, but let us move further and then see what we learned from this 1960 tsunami signatures. So, earthquake occur when the fault rupture suddenly release the built up energy. This was shown in one of the cartoon movie, where slowly the locked area will result into the development of the strain and the deformation of the overriding plate, which can result into either subsidence or uplift of this region, but this will be a very slow process and can be picked up based on the if you are having the GPS stations. So, if you have multiple GPS stations, you can easily make out the change in the elevation or the deformation which has been experienced over the time, but this will be a very slow process. So, it will take years, and as I told that in terms of the 2004 type tsunami, the recurrence is around 400 to 500 years, but the source can be anywhere in the subduction zone. So, what it explains the similar pattern what we have seen in the movie, that initially the overriding plate and the subducting plate will keep on moving, and it is shown by this arrow, but the locked area will result into the deformation of the overriding plate, and finally when the energy is released or this the overriding plate slips, and this has been shown by, so this portion has been shown by the dotted lines here, and what we see is that there is an uplift here. So, the land has moved up, and then at the time of the release, this is the land which was uplifted, and at the time when it was released, it has come to this level. So, it got, this is what we call the subsidence. So, the land level change is very prominent at the time of the major earthquakes, or what we call the mega earthquakes along tsunami along the subduction zone. And finally, what we see is the inundation by the tsunami waves which spreads over the region. So, these are few signatures which we observed when we did field survey in Maulin in Chile, which was in the epicentral area. This is the area which has been shown as a ruptured area, and the survey which was been conducted here was very important in terms of that it was close to the region of the subduction or the rupture area as well as the subduction zone, and the evidence or the interviews which were been conducted from the survivors helped us in identifying even not only the 1960 tsunami deposits, but also the older one which we call as an paleo tsunami deposits. So, So these are some satellite pictures which were taken just after that, and which shows the path of incoming tsunami. And this bridge was destroyed by the first wave which entered into the Shurain area. So these were the pictures from the town of Moulin. This is quite interesting. This picture was been taken before, and you can see that there is one of the major river which is flowing along this one, and in the floodplain area there are some residential houses, and this area was earlier been used for agricultural practices. But just after that, what you see is only few trees were been left out, everything was been wiped off. And then, since this area is close to the coastal region, the tidal inundation was quite frequent, and this area was like people were forced to leave this area because it is now getting inundated during the high tide. So again another good indication of that. So the first wave arrival which has been seen here, and then second one which has wiped off the small hut which was been seen in the previous photograph. Now this photograph is from Japan, and as I was talking that the tsunami was been coined by the word was been coined by Japanese people, so they had like better understanding, or still they are now, of course they are having a better understanding than all of us, because they have such events very frequently occurring in their area. So the tidal station person found that there is some change in the tide level. So he quickly informed the people in the nearby region and asked them to move on high ground. So this is what you see, the people have moved on the high ground, and this guy is running. So the first wave, it just inundated this area. So water entered from here and just inundated this portion. So still the people have time to run up, and they very well understood that there will be a second wave which will be powerful. So this was the first wave which just came and flooded the area. The next one was powerful. So if you see the timing in the previous photograph, it is 4:40 a.m. and the another photograph which was been taken just in 5 minutes of gap. So the impact of the second wave was much more devastating. So this is what we were talking about, that you should not consider that all waves will not be as powerful. Like if the first wave is coming, we should understand that it could be a calm wave, but the second wave could be a powerful one. Third, and just after 5 minutes again the water rose and more like destruction was being experienced, and finally at 7:30 you can see that water reached up to this portion. So the previous one, if you look at, water reached as this one, and then this was the one. So the station, the train station which has been shown in the next slide is this one here. So window were still intact at the second wave. It was broken, pushed inside, and then a lot of debris was there along with that. The window is gone. So again, coming back to Chile, what we found is that there are remnants of some jetties which were been constructed for getting into the boats, but now it is lying in the submerged tidal flats. So this is during the high tide, it gets submerged, so nobody is using this area anymore, and the soil which was used, or the area which was been used earlier for agricultural purposes, now it is under erosion. And the another good evidence which you can see is of dead forest, because of the inundation of the saline water, the vegetation or the trees which were growing in this floodplain area will not survive. So, this is the indentation, and so this type of signatures are very crucial for us, and what we can see is the constant soil erosion which is going on, and this was the fertile soil. So, you can see the soil erosion, constant soil erosion, and the picture which I was showing, the black and white picture, was from this area where people used to stay, but few who survived from this, they moved to the high grounds, and now they have settled here on this high ground. And in most of the evacuation process, the areas which are like prone to such tsunami events, they will put the sign for the people if there is a tsunami warning to move on high grounds. So, this is one of the best way that if you understand the phenomena or the process, then immediately one should move on the high ground. So, now this whole area is getting converted into tidal marsh, and people have moved on this higher grounds. So, this is what it shows, the erosion and the previous soil which is now under the tidal erosion. So, what we do is basically we try to study the tsunami stratigraphy. So, we if you dig the subsurface and try to see the different lithology. So, whenever there is an event which has occurred in the past or which will occur in the past, will get preserved in the sediment records. So, this was a simple way out, and we did, and very promising results were been obtained. So, we were having the team from one of the renowned tsunami geologists from US, Brian Atwater, myself here, person from Chile, and these two guys are from Indonesia, and another scientist from India. So, what we found was that there was like very clear cut demarcation or sharp contact between the blackish soil which was at the time available on the surface during 1960, and then there was a deposition of the tsunami wave, tsunami sand during 1960 event. So, the diagram here, it explains that you have before you are having in soil here, then you have like during an earthquake you have subsidence. For this is, for example, if the land goes down, then this level has reached here, and then tsunami will come. So, first what you have is the earthquake. So, any region when first will be an earthquake, that will result into either uplift of the area or subsidence of the region, and followed by this, that is ground shaking and the displacement, tsunami will be generated. So, tsunami wave will arrive later, but before the arrival of the tsunami wave, this process will take place, either it will get uplifted or subsided. So, in this case, what has been shown here and in what was observed during 1960 earthquake was subsidence, because the area which was been used for agricultural purposes is now getting inundated during the high tide, and that indicates that the area has subsided. So, sea level has remained same, sea level did not fluctuate, but the area subsided. So, what we see here is that you have the sand which is coming in and then was deposited, and later after years of erosion and the next phase of deposition, what we see is that this unit is preserved, and then we are having another set of soil which is coming up, and then we have vegetation which is. So, this signature of the sediments or the tsunami sand got trapped between the two soil units. So, this is 1960 surface. So, and then the tsunami came in 1960 event, and then there was a soil formation here. So the next event when it will come, it will deposit on the top of this one, and then again same process goes on. So what we see is the couplet of the soil sand if it is an ideal condition. Of course, there will be some regions within the area, same area, will undergo more erosion because of the burrowing activities, which has been shown here. So this will destroy to some extent the deposits, or it will not allow the full preservation or the signatures of the tsunami in the tidal flat region. So if you look at the section from Moline, then what we see is that we have soil, then soil here, and in between we are having some sand units. Okay. So this clearly indicate that there were repeated events in this region, which definitely affected the area in the past also. So this was not the only one which was responsible for such sort of a devastation. So we had another one is 1575, and then during 1280 to 1390 AD, and there was another one in 120 and 1190. So what we basically identified in this, that we were having multiple events, and based on such type of investigations, we can identify the paleo tsunami events. So this was the slide we prepared just after the visit to Chile in 2005, and that what we did was as a future initiative. So we applied the same technique in Andaman to identify the paleo tsunami and paleoseismic. Paleoseismic is basically we are talking about the signatures of mega earthquakes. So I'll stop here and we'll continue in the next lecture. Thank you so much.